Hi, my name is Ted Neward, and I'm here to talk to you today about .NET Standard, what it is, what it provides you, and more importantly, why you should care. I've been around this industry for basically a quarter of a century. Currently, I work as the Director of Developer Relations for a company called Smartsheet. But the more important part about this discussion with respect to my experience is the fact that I actually cut my teeth as a C++ developer way back in the ancient days of Windows 3.0 and DOS and a couple other operating systems, most of which don't exist anymore. I've seen a lot of different things, and I've seen a number of efforts that are going down some of the same paths, at least on the surface, that what we see with .NET Standard. So we're going to talk a little bit about .NET Standard. We're going to go over some of the technical details, but along the way, I'm going to sprinkle in some experience that, well, frankly, I and some of my peers learned the hard way back in the day. To understand a little bit of .NET Standard's purpose and to understand a little bit of where it's trying to go, it helps to understand history. There's a great quote by a historian by the name of George Santayana that says, "Those who cannot remember the past are condemned to repeat it." So let's see if we can avoid condemnation, shall we? The CLR's history is long. Matter of fact, this technology has been in incubation since about the year 2000 was when Microsoft announced the alpha at their PDC way back in the day, an ancient predecessor to Microsoft Connect. And it's important to understand some of that history in order to understand what the CLR was trying to do, which then in turn tells us a little bit about what .NET Standard is trying to do and where it's going. In the beginning, there was this language called Java. And more importantly, it was a platform. It was a number of different things. It was a language, it was a managed runtime, the Java virtual machine, and it was a set of libraries. And quite frankly, we could use it to write all sorts of different things. Microsoft had their own runtime at the time. It was known as the Component Object Model, or COM. Many of you won't actually remember COM days, but as a matter of fact, this is still a fundamental technology underlying a lot of the Windows infrastructure that we use today. The thing about COM was it was an unmanaged runtime. That is to say, we wrote components for COM using unmanaged languages like C++. And that in of itself had a number of problems. Maybe not problems, had a number of frailties, certainly. For example, if you dereference a null pointer inside of C++, you'll crash the entire process, and that generally is not a great thing to do to your program or to your users. Microsoft looked at the JVM and realized that here was a managed runtime that actually executed managed code as opposed to a managed runtime which was trying to execute unmanaged code, native code. And they said, this is a good thing. We should actually have some more of this. So Microsoft was a great adopter of Java at the time. They actually built their own Microsoft virtual machine, the Microsoft JVM. For a number of years was actually the fastest JVM running on Windows. And they built a number of developer tools around that, including J++, which made it very easy for you to use the Java language to write COM components. And they were happy. The problem is the principal owners of Java, that is to say the now defunct Sun Microsystems, they were not happy. In particular, they were not happy that Microsoft had said there were two features of the Java environment, that is to say Java native interface and Java remote method invocations, that don't make sense when we're running on top of the Windows platform. So Microsoft, you need to implement those features even though they're actually redundant when running on top of Windows because the Microsoft JVM had some nice hooks into the COM platform, which provided it native access as well as remote access. Microsoft said, well, no, I don't think we do need to do that. We're going to stick with what we've got. Sun said, oh, no, you will change it. And they took them all the way to court. And this, of course, was the famous Microsoft-Sun legal battle that ultimately led to Microsoft's banishment from all things Java. Microsoft said, okay, we're going to pull Java out of everything that we ship, and people will now download Java from Sun, and yep, Sun, you win. But Microsoft had seen the promised land. That is to say, they had seen all of the advantages of running inside of a managed runtime. And what they found was that managed runtimes are actually very powerful. And for starters, we get garbage collection, automatic memory management, and that's a really difficult thing to surrender as a developer because, quite frankly, love means never having to say delete. So Microsoft basically said we liked what we saw in terms of executing on top of a virtual machine. We liked the environment that it created. There were a couple of philosophical differences that we had with Sun in terms of what should be allowed and what shouldn't. But for the most part, we kind of like the place that Java led us to. So since Sun has decided that we cannot be players inside of the Java world, well, we'll take our ball and go home. We'll create our own runtime. Specifically, though, Microsoft said we want to make sure that we can support multiple languages. Remember, this is the time when Microsoft had two very popular programming languages, the aforementioned C++, and of course, the ubiquitous Microsoft Visual Basic. They wanted to be able to support both of those. They wanted to be able to support any features of the underlying operating system that were really important. And of course, performance was always going to be a very big deal to anybody building anything for use by Microsoft, at Microsoft, for all of Microsoft's customers. So this runtime effort was begun, and it's actually gone through a number of different names. Back in the earliest days, it was known as COM+. As a matter of fact, rumor has it that this, what we now call the .NET runtime, was actually supposed to be what COM+, it was supposed to be COM+. And Microsoft basically kept sort of shelving it, or at least some of the ideas continued. And yeah, COM+ later became something completely different with respect to managing transactions and so forth. But they then renamed the runtime to the Component Object Runtime Core. As a matter of fact, this name lives in a number of places inside of the runtime. If you do any unmanaged access to the runtime, such as creating an instance to run inside of your own process, you're still using interfaces that start with iCore, the I Component Object Runtime whatever interface. Later it got the name the Universal Runtime, or IRT, which I'm kind of glad we didn't go with, as well as Next Generation Windows Services, NGWS, which I'm also kind of glad they didn't go with. Ultimately, they settled in on the name .NET, and the world as we know it came to be. But Microsoft also understood that they didn't want to create something that was proprietary. They actually wanted to play nicely with the other children. They wanted to make sure that other companies could take advantage, make use of, etc., this particular runtime. So they did what Sun didn't. They actually approached industry standards organizations. In this particular case, they went to the European Computer Manufacturers Association, ECMA, and they asked specifically to create two standards. Number one was for the C# programming language, which was ECMA 334, as well as what's known as the Common Language Infrastructure, which was later given ECMA 335 designation. Microsoft was not the only big industry player to do this. They were actually joined by Intel, HP, and a couple of other supporters. And the latest version was actually released about 5 years ago, the 6th edition, back in June of 2012. That takes us up through what we would consider, those of us on the Windows platform, that's what we would consider to be .NET 3.0. Now, one of the things about creating a standard, a specification like this, is that there are going to be, well, it's expected there are going to be, and there turned out to be, multiple implementations of the ECMA 335 Common Language Infrastructure specification. The most popular one to the people watching this video, of course, will be what we call .NET. This is the implementation that runs on top of Microsoft Windows, and more formally is known as the .NET Framework. Mono, of course, was an effort created by Miguel de Icaza back in the, well, 2000, 2001 timeframe, after he started playing around with it and said, this is pretty good, but I don't want to have to run Windows to do it. I want to actually run this on top of Linux and some other operating systems. So he created Mono, which was later acquired by Novell and then cut loose and became Xamarin, which then, of course, became the mobile language, mobile platform that we all know and love today. Microsoft actually had a second implementation that was known as the Shared Source CLI, aka Rotor. As a matter of fact, one of the books that I wrote was on the Rotor implementation, and contrary to what a lot of people believe, it was actually Microsoft's first open source implementation of the .NET runtime. It was stripped down in many respects. It lacked a lot of the Windows-specific features, but Rotor was very interesting from the standpoint that all the source was available. And by the way, I've compared the Rotor code base with the .NET Core code base that we have today, and there's a lot of carryover. I would estimate probably 60 to 75% of the code carries over from then. But more importantly, Rotor was actually portable. the rotor implementation was written in such a way that it could in fact run on platforms other than Windows. As a matter of fact, originally it was targeted at Windows and FreeBSD, which is a Unix implementation that's by its name obviously open source and free. But more importantly, because it was BSD friendly, it actually took very little work to convince it to run on top of the Mac operating system. So even as far back as 2002, 2003, Microsoft had been thinking about this notion of reaching out to other platforms. It took them a few years to actually get to that point. Well, let's be blunt, it took them about 15 years to get to that point. But we're here. Microsoft also, of course, has more recently released .NET Core, which is their shared source implementation that's governed by a more industry standard license. The code is all available on GitHub. And more importantly, .NET Core is explicitly designed to be multi-platform, thus giving Microsoft an opportunity to bring .NET to a number of platforms that you may care about that maybe aren't called Microsoft Windows. The key thing to understand here is that there have always been multiple .NET implementations, and again, to use the terminology precisely, there have been multiple common language infrastructure implementations, and that's the important thing. This is not new ground when we start talking about .NET Standard and its capabilities. It helps to understand a little bit about what the CLI provides, because in many respects, .NET Standard is not an attempt to replace this. The CLI itself, for those of you who are curious, is broken into 6 different documents, what they call 6 partitions. And the idea behind the CLI spec, in the words of the authors of these documents, is that we want to bring a unified type system. We want to package types into self-describing portable units, aka assemblies. We want to be able to load types in a way that they can be isolated when necessary. This is kind of the whole app domain concept, which was considered to be really important at the time and probably isn't as much today given the whole rise of containers and Docker and whatnot. We want to be able to understand inter-type dependencies using flexible binding. We want to be able to represent type behavior, aka we want to be able to understand bytecode in a way that's verified as type safe, meaning we have a overarching omniscient entity, that is to say the security manager, who's able to look at all of that bytecode and make sure that you're not doing something illegal. It's not so much a security feature as much as it is a reliability feature so that you can't accidentally do something that would make your code break at runtime. Perform processor-specific tasks, such as laying out memory in an optimal fashion, in a way that can be deferred until the last moment, but don't penalize tools that do these tasks earlier. One of the things that Mono does, for example, is ahead-of-time compilation. It looks at your bytecode and transforms it into machine-specific CPU instructions long before it's actually executed. This is of great benefit where we're running on top of smaller platforms like iOS and Android. But remember that security manager is there. It's an omniscient entity, and it's designed to make sure that you can't do anything to break either the user's code or your code or get access to things that you shouldn't have, etc. Lastly, and probably most important from the .NET perspective, is this notion of runtime services. We want to make sure that the environment can provide a number of interesting things to developers at runtime, aka garbage collection, automatic memory management, and so forth, but more importantly, do this in a way that will allow for future things to be ninja'd into the .NET runtime without having to actually go back and make significant heavy source code changes. Given the fact that this was all written in 2000, 2001 timeframe, and we're talking about a platform that's now been around for 16 years and has seen a pretty hefty amount of innovation, I'd say that they actually were able to accommodate new inventions and future changes pretty gracefully. The spec itself covers a number of different areas: the common type system, metadata, the common language spec, which describes how languages work together, and the virtual execution system, which describes basically the runtime. And the important thing to understand about this is to understand that .NET Standard doesn't actually take any of this stuff away. If anything, the .NET Standard is going to sit on top of the CLI specification, and this is important to understand its place inside of the universe. The common type system is what provides us with the type-safe guarantees and gives us both managed code and managed data. The metadata tools are what we use to provide a lot of these facilities as part of the runtime. And CLS compliance is specifically talking about who gets to be a language provider and who gets to be a language consumer. Again, none of this is going away. It's important to understand that all of this is still in play, And so, for example, if you're contemplating creating your own language on top of .NET Standard, you're actually going to be writing to the CLI specification. This is fundamentals, if you will, of .NET Standard. If you're interested in diving into the CLI specification, these are the parts that I would suggest you look at, particularly if you're interested in getting below the level of the language itself. If you ever wanted to understand, after C# has compiled your code, while it's running, what is the runtime doing for you? All of these will be useful, particularly partition 3, which is a complete reference to the .NET bytecode set, also known as the Common Intermediate Language. But we're here to talk about .NET Standard, so let's talk about that for just a second. The first question is, of course, what is it? And part of the reason I've been spending so much time talking about specifications is because that's what .NET Standard is. It is a specification. It is a declaration on behalf of Microsoft to all of the developers that want to use this platform that when you build something that targets .NET Standard, there are these things, and there's a whole list of things, mostly APIs, that will be present on this platform when you start working. It's a set of APIs, if we want to use layman's terms, it's a set of APIs that anything that calls itself .NET Standard compliant must implement. It has to be there, otherwise it's in violation of the specification and presumably isn't useful to you. Now, currently, there are 4 .NET Standard implementations that Microsoft ships, and bearing in mind there's absolutely nothing stopping third parties from building implementations that comply with the CLI specification. And in fact, if they want to be .NET Standard, then they'll have to provide the APIs that the .NET Standard requires. The interesting thing about this is with successive versions of .NET Standard, all 4 of these implementations have had to make some slight engineering changes in order to accommodate the things that .NET Standard provides. There is, of course, the .NET Framework, which is running on top of the Windows platform. For 90% of the people watching this video, that is .NET. That is the only .NET that you've ever known, and it continues to exist and continues to go forward. There is .NET Core, which is the open source version of .NET. This is going to be your cross-platform story. This is going to be your Docker story. And for all practical purposes, this is Microsoft's path forward beyond here. There is, of course, Xamarin, which we know and love for writing code to mobile platforms, as well as to non-Windows platforms, that is to say Mac OS and Linux and some other environments. There's also the Universal Windows platform, which is specifically looking at a lot of the devices. Predecessors to these implementations include things like Windows Phone. There's actually another implementation that Microsoft is working with to bring it up to .NET Standard, and that, of course, is Unity, which is the big 3D gaming, VR, augmented reality, very, very sexy HoloLens kind of technology. It's not currently, as of this recording, it's not a .NET Standard compliant implementation, but Microsoft is working with the folks at Unity to bring it up to that speed fairly quickly. Given the fact that Unity is actually using a source forked version of Mono for their implementation, chances are there's not a lot of engineering that needs to go on in order to bring them up to .NET Standard compliance. So I'd be willing to bet that by the time calendar year 2018 rolls around, Unity will be on this list. And so here we see sort of visually this notion of how these things are going to work together. We can see Windows applications written on top of the .NET Framework. And this, by the way, encompasses a whole bunch of legacy stuff. So for example, if you've got some old WinForms code, that can in fact be considered .NET Standard because WinForms runs on top of the .NET Framework, and the .NET Framework is a .NET Standard implementation, so we all good. .NET Core, of course, just talking about that, that's going to be for a lot of your server and Docker implementations. And then, of course, Xamarin and UWP for your more mobile applications. Notice that all of them sit on top of the .NET Standard, and notice that the .NET Standard box here encompasses libraries and infrastructure. That is to say, the compilers, the runtime services, the various languages, C#, Visual Basic, and of course my favorite, F#. All of these are considered to be part of the .NET Standard, and therefore all of these are things that you can assume are available to you when you actually start working with it. The important thing to understand about .NET Standard is Microsoft is not going after write once, run anywhere. They're not actually trying to create these cross-platform applications. What they're trying to do is they're trying to give you a firm basis, a firm base on which to build your applications and know that certain behaviors will be there. The CLI specification in particular, one of its authors told me once that their goal in many respects is to allow the underlying platform to bubble up through the runtime to developers that want to take advantage of it. If there are particular features of, for example, the Windows operating system that you want to take advantage of, such as the Windows registry is one of the common ones, we want to allow that functionality to continue to be accessible to you. So .NET Standard in of itself, it isn't an actual implementation. It's a promise. It's a guarantee that certain things will be there when you start working with it. Let's actually examine some of this for just a second. Let's go ahead and bring up Visual Studio. And all I want to do for right now is I just want to create a good old-fashioned console application. So we're just going to go ahead and create a console app. And actually, I'm going to do this in a slightly different directory because I actually want to be able to play around with this a little bit in a way that wouldn't be immediately obvious to us. We're just going to call this the sample solution, which will have the console application in it. And let's create this. And lo and behold, we have here a firm basis from which we can do the ubiquitous hello world. Excellent. And if we run this, like so. Oops, sorry. If we run this like so, there we see hello world. This is everybody's .NET 101 getting started hello world application. Now, the interesting thing is most applications aren't written in just one file. As a matter of fact, most applications aren't written in one project. Frequently, we have a number of different modules, a number of different, some sort of structural categorization to our code so that we can keep an eye on what we're doing. More importantly, as we have seen, the world is not a mono-development environment. The world is not all just Windows. Microsoft of 25 years ago thought that they could conquer the world by having everybody run Windows. Microsoft of 2017 says, you know, there's lots of platforms out there, and rather than try to fight with everybody, let's actually try to play nice with the other children. So more importantly, they want to be able to allow Microsoft .NET developers to be able to work on all these other platforms. That's part of the reason why they acquired Xamarin. But in order to do that, we often want to create some shared layers. We often want to create some sort of bits of code that we can actually, well, dare I say it, reuse. We want to actually have some code. If I talk about the concept of a person, I often want to work with that person inside of my ASP.NET application where I'm working with it on the server, but I'm also sending representations of that person across the wire over to a client, which in some cases may be iOS or Android, or even if it's another Microsoft implementation, it's still running on the client, which is a completely different implementation. Maybe it's, in the old days, it would have been a Silverlight application. Perhaps it's going to be something else down the road. Who knows? The point is, if I actually have some code that I'm going to share just to break out, I'm often going to do that in the form of some additional project. Now, historically, we would create this as a class library. In other words, we want to build another assembly that gets compiled, and this class library may contain some data transfer objects that we're using to shuttle back and forth between our client and the server. However you want to structure your code, there will often be a need to create a class library that holds these types that we want to work with. Now, if I create this as a .NET framework implementation, it means, unfortunately, that it's probably not going to be usable on an iOS or Android or any place other than .NET Framework. It would actually be better if I could say, I want this library to be something that can be shared from multiple places. And this is exactly where the .NET Standard comes into play. If we select over here on the left-hand side, .NET Standard, we can see that class library .NET Standard is available to us as an option. What this tells the Visual Studio environment is I want to compile this according to .NET Standard rules. I want to make sure that I know I'm targeting the .NET Standard or any, to be more specific, any .NET Standard compliant implementation. So we're going to create this class library, and I'm just going to call it the people library because it's going to have one class inside of it, class person, to represent persons that I work with. Now, fundamentally, doesn't look any different from any other class library that we've created in the past. Now, fundamentally, this class looks the same as anything else we've done in the past. So we'll just create a person class here, and we'll just give it a couple of very simple things. Public string, first name, oops, get set, and, let's give people a last name too, why not? The actual contents of this class are not really important to the demo. The important thing is to note that if I want this console to make use of this, well, we have to do the same things that we've always done inside of Visual Studio. We have to add a reference. We have to say that we're using the class library here so that we can make use of it. So that now back here in the original code, you can see that it's added there. Here we can say using people, and I can create a new person, var p equals new person. So we can simply do first name equals Ted, last name equals Neward. This is, again, very, very similar experience to anything we've ever done. And we can just do this, whoops, p dot first name, like so. Okay, and again, we build it, we run it, and it's all the same basic story. The key thing to understand here, though, is that this class library is now actually a .NET standard implementation, which means it'll be accessible for us in a number of other places. For example, now we've reached a point where we want the application to be something that we can actually build for on iOS. And obviously that would mean that I have to have a Mac sitting next to me here, and I have to fire up Visual Studio for Mac, and I have to select that I'm creating an iOS application, and I have to think about views and view controllers, and I have to think about delegates, all of those lovely iOS goodness things that I deal with when I build an iOS application. The key thing here, though, is I don't want to have to rewrite class person, because this would be a violation of the DRY principle, the don't repeat yourself principle. If I express a concept in a language, I want to express it in one place, particularly because if I later change some notion of that concept, if I later come back to my class and I say, you know what, people really should have age. Maybe we need to track their birth date as well, so we know when they were born, we can track how old they are. Maybe because we're looking to hand out a beer to everybody who's over the age of 21, or we're looking for people who are eligible to retire and that sort of thing. All of that should be captured in one place. And we want to capture that as part of this class library. That's the important part here. So assume that I have this library. I don't want to have to just copy the source code over, right? That's not reuse. That's just copy and paste use. And more importantly, it doesn't track the commonalities between these. What I would really like to do is I would like to use this notion of the people class library as part of, say, a Docker-based application. So let me drop over to a command prompt. And specifically, I'm going to go into my projects directory. And notice here I have my .NET Core, right? There's my sample application that I've built. But now what I'd like to do is I'd like to actually build a Docker-based application. Well, fortunately, Docker is amazing in the sense that it allows us to be able to make use of images that are stored up on Docker Hub. So I have a very simple .NET Docker image under my Ted Neward account on Docker Hub that has the .NET framework, .NET Core, stored inside of it. Okay? And notice that I'm using a volume binding there to allow it to access the current directory, that is to say my projects.NET Core directory, but I am definitely here inside of Docker land, right? If we go look at the root, I mean that clearly bin boot dev, etc. That's clearly a Linux implementation right there. If I use the .NET command line, notice that I can actually tell it I want to do a variety of different things. I want to, for example, I want to create a new project, which we'll use in just a second. I want to run a project. I simply want to build it. I want to publish it as a part of NuGet. Oh, which reminds me, it's very likely that if I'm using this library across a number of different places, I probably should package this thing up in order to be accessible via NuGet. Even if I'm doing internal enterprise development, if I have other teams that are depending upon this project, I want them to depend on the built artifacts, which means I really want to track this thing as a NuGet package, which actually is relatively trivial to do inside of latest versions of Visual Studio. Specifically under the project properties here, notice that we have a package option, and now generate NuGet package on build. And what we'll see in terms of the output, if we go into the debug directory where that sample is located, let's go back to the Docker command here for a second. Let's go into sample. Let's go into people, sorry, that's the name of my library. And if we look at bin, debug, notice now we have a NuGet package here that will actually describe everything that's coming inside of here. Rich Lander and Emo Landworth have a video from .NET Conf that actually talk a little bit more about some of the functionality here. But this is actually really nice to have because literally with the check of a box, I now have something that's easily publishable up into the NuGet atmosphere. Gotta love the cloud, right? So I've got this library, and now what I want to do is I'd like to actually create a new Docker console application that will make use of this. So .NET New, again, now this is all .NET Core. This is not .NET Framework. I'm using an entirely different .NET implementation. And if I say .NET New, notice it's giving me a list of all the different templates that it knows how to create. So .NET New, again, I'm just going to keep it simple and call it a console app, and we'll just call it .NET app. Oops, I need to give it a little bit more in the way of information. So let's do .NET console, .NET New console help again. And specifically what it wants, basically it wants to know a name and it wants to know the direction, the place in which to put this stuff. So .NET New console, and we'll call it .NET app or Docker app. Let's call it Docker app. That sounds more interesting. Now, what it's done is it's scaffolded out some applications here. It's scaffolded out some application code. More importantly, it's created this directory called Docker app in which we see program.cs. Now again, if I want to make use of this other library, in this particular case, I'm just going to point it up one directory and over. So .NET, let's see, everything inside of the .NET Core is all done in terms of this .NET tool. But if I want to reference another project, let's see, there's got to be a command to do that here, right? Let's see, .NET New, restore, run, build, publish, test, pack. Notice we also have the same tools here for doing .NET migrations. I'm sorry, NuGet packages. Notice we have migrations. That's actually for an older version of .NET Core. Clean, solution, add a reference to the project. So .NET add help. And notice here what it's saying is that, get up a little bit further so we can see more of it. There it is, .NET add options, the project is mandatory, and then the command we want to actually do. So what I want to do is I just want to have a reference to the other one. So inside of my Docker, my .NET Core Docker app here, .NET add, and the name of this thing is Docker app.cs proj. That's the name of my local project. And I want to add a reference to people. And again, here I just add a reference to the CS proj for it. Now it says that it's been added. Great. What I want to do at this point is I want to actually change this program.cs to reference the class library. So I'm just actually, since all of this is happening in the same directory, I'm actually just going to use Visual Studio as my editor and do a file open. And we'll just grab that other program file. So there's Docker app. Bring this guy up. Notice, again, looks very, very similar to the .NET Framework one because, hey, it's a console application. We're not getting too fancy here. But we can go ahead and say using people. And then we can do the same thing here. var p equals new person. first name equals Ted, last name equals Neward, like so. Now again, IntelliSense isn't kicking in here because we're just using Visual Studio as an editor. Hello world from and p.firstname. Okay. Now, normally, if I'm actually building this application on another platform, if I'm building it, for example, for iOS, I'm going to use Visual Studio for the Mac, or I'm going to use VS Code. I'm going to use tools that are more appropriate to that platform. I'm just keeping it all inside of Visual Studio here for convenience as a part of this discussion. But more importantly, when I come back to my Docker window here, notice if we look at program.cs, yep, it's referencing people. We're using the person type. Let's see if it builds. Build succeeded. Let's tempt fate. Let's see if it actually runs. Oh my gosh. Think about what we've just did right here. We are actually creating multiple applications that are using a shared library. Now, in this particular case, this is Docker, and Docker is running a flavor of CentOS, which is a flavor of Linux. But the more important thing to understand here is I have built a library that can now be used across different application front ends. One of them is a .NET Framework console application. The other one is a Docker console application. So yeah, they're both console applications. I know, it's hard to get excited about a console app. But I'm simply doing this from scratch to show you that there's really no smoke and mirrors here. There's no magic. By the virtue of the fact that I've created this class library to target the .NET Standard, anything which implements .NET Standard thus guarantees my library that it will have a surface, it will have a runtime, it will have a whole bunch of APIs available to it in order to be able to do whatever this class library needs to do, that will then be accessible to any of the platforms that .NET Tooling can target. Now, the important thing again to keep in mind here is that at no point was I ever running .NET Standard. .NET Standard is just a specification. It is just a declaration saying these things will be available to you anytime you run on top of a .NET Standard implementation. So when we run on top of the .NET Framework, you'll have your APIs there. When you run on top of Mono, you'll have your APIs there. When you run on top of Xamarin on iOS, you'll have your APIs there. This is important. But again, it's not a write once, run anywhere story. The whole point here is to allow us to reuse code across these platforms, but we don't want to try to create the single graphical user interface library that runs on all of them. That would actually be a lot more work and, to be honest with you, a lot of wasted effort. I've personally been through 2 different platforms that tried to go down this write once, run anywhere story. The most obvious one, of course, is Java. Java explicitly targeted write once, run anywhere. They patented the acronym for all intents and purposes. And one of the things I know from my Java experience is that write once, run anywhere frequently turns into write once, debug everywhere. And that is a path that I would prefer everybody not have to go down. But also before Java, there was another attempt in the C++ world to create all of these cross-platform GUI frameworks. I remember the days of Zinc and ZApp and RogueWave and all these other libraries that said, look, you just write to one standard user interface API and we'll build it on whatever platform you happen to be on, Windows, OS2, OSF, Motif back in the day, and we'll build you a user interface, which usually meant that it looked terrible everywhere. This is where we get the notion of a least common denominator approach. .NET Standard isn't going after any of that. If anything, what it's trying to go for is creating the largest surface area across all of these platforms. In some respects, it's similar to what jQuery tries to do. jQuery doesn't say, let's take the absolute minimum subset of each browser and expose that. jQuery says we can do some polyfills on different browser implementations in order to give you behavior that you're expecting that maybe the browser simply doesn't provide. This is an important realization that this notion of .NET Standard is not for all of your code. Specifically, they have this notion of application models which is to say the code that's usually at the top of the stack, your user interface code, your iOS code with views and view controllers, your Android code with activities and views and fragments, your .NET Framework WinForms code or your XAML code, that's all going to remain generally pretty target specific. It's the other parts of the code that aren't really dependent upon the underlying platform, such as my people library. That's the part that we really want to know that we have a surface area on which to work. Now, the interesting thing is that runtime library support is actually pretty extensive. We'll get a sense of that in just a second. But notice that each of those colored boxes up there at the top is not officially part of the .NET Standard. And quite frankly, hopefully, never will be. Because the point is to let the platform do what it does best. Let us take advantage of the various iOS features rather than trying to rebuild iOS on top of Android. We don't want to try to polyfill all of the user interface stuff. What we really want to go after is those libraries that your business logic, your application code that isn't user-facing, that's what we want to be able to depend on. That's what we want to be able to see when we start building a lot of these. Now, one of the things you'll run into fairly quickly when we talk about the .NET Standard is you'll see there are a large number of different version numbers. As a matter of fact, if we go back to my Visual Studio here for just a second, and we go back to the properties for the people project, we'll see specifically that we can actually target a lot of different version numbers, 1.0 all the way through 1.6, followed by 2.0. The important thing to understand about these version numbers, first of all, is that none of these are breaking changes. Microsoft has heard from the community that said breaking changes bad, horrible idea for a specification. Let these all be forward compatible changes. And .NET Standard 2.0 is simply the last version of this standard, largely because it represents a pretty dramatic size jump. From 1.0 to 1.1 all the way through 1.6, those were incremental steps in terms of the number of APIs that were provided by .NET Standard. .NET Standard 2.0 like doubles it, order of magnitude. It's some ridiculous large number. I think the number I've heard is like 32,000 different APIs are available as part of .NET Standard 2.0, which is huge. Absolute, again, order of magnitude growth over .NET 1.6. Enough so that they thought it merited a new version number. But I can target any one of these versions here by simply selecting which one that I want to target here. And I can do the same thing from a variety of the other .NET Standard targeting tools. Now, the important thing is to note that future versions will add. This is all going to be additive representations. Microsoft is not interested in trying to create the trim solution. There was an effort within the early days of the ECMA specification to be able to create different profiles, what was known as the base profile, the kernel profile, et cetera, et cetera. There were like 4 different profiles, if I remember correctly, that were offered by the CLI specification. And this is not an attempt to do that. .NET Standard says when I choose version 1.6, this is exactly the version that I'm going to support. Now, future versions of the .NET Standard may not stay in lockstep with implementations. This is an important distinction. .NET Standard currently is at 2.0. .NET Core is also at 2.0. That is just coincidence, quite frankly. .NET Core will be versioning on its own, and .NET Standard will be versioning on its own. So .NET Standard 2.1 may in fact be implemented by .NET Core 2.5 or 3.0 or 173 if we just decide to give up on version numbers entirely and just go to incrementing numbers. So to keep track of all of these different versions can actually be kind of tricky. And Emo Landworth, who is one of the principals working as a part of .NET Standard, has actually created this rather nice interactive HTML. Let's go see if we can find it, see if the interwebs are working for us. Here we go. emo.landworth.net/netstandard-versions. By the way, the code for this is available on Emo's GitHub account. But notice here, this drop-down here allows us to select version 1.0, and this dark green area tells us all of the platforms that implement .NET Standard 1.0. If we go to the other end of the spectrum and we look at 2.0, well, basically we can see that .NET Core 2, .NET Framework 4.6.1, Mono 5.4, et cetera, et cetera. These are the versions of the implementations, which is this list down the left-hand side here. This is what implementation version corresponds to .NET Standard version. Now, one of the things you look at here is obviously if I'm targeting .NET Standard 2.0, I'm currently leaving all of my Windows, Windows Phone, and Windows Phone Silverlight customers out on the cold. All right, Silverlight folks, I hate to break it to you, but Silverlight is dead. I probably don't care about you. Just saying. The Windows Phone folks, well, if you're not dead, you're on life support. Windows, well, okay, that's a little bit harder group to just write off. And so what you're left with is kind of this discussion of, well, gosh, which version do I want to target when I'm building .NET Standard implementations? And this is one of those cases where, quite frankly, the answer to it is relatively straightforward. The answer basically is that you want to target the lowest level implementation that you possibly can. Now, the .NET Standard environment provides a whole bunch of this, right? There's a whole bunch of these features here, and gosh, surrendering all of these 2.0 features would be really, really hard, right? And .NET Standard, I mean, it's got a compatibility shim which will allow a number, 70% is the number that Microsoft tosses out, of existing NuGet libraries. Again, Emo and Rich have an example from .NET Conf that show making use of, for example, data tables, data sets. Oh my gosh, data sets. I feel like we're back in 2001 already. All of that stuff is accessible in .NET Standard 2.0, at least the arbitrary high-level parts of it. They're not putting SQL Server as a part of .NET Standard 2.0, but they do have support for a lot of the system.data classes that served as the base on which ADO.NET implementations were built. And I have all of my Xlink, I have all of my system.xml types. Wow, this is a ton of stuff inside of 2.0. I don't want to give that up. But at the same time, I don't know which of these versions do I really want to target in order to be able to, build my application. Should I go after 1.4? Because, well, again, that leaves my Windows Phone customers out in the cold. More importantly, I don't have to go and tell everybody to upgrade to .NET Core 2.0, et cetera, et cetera. This is not always an easy decision to make because, very frankly, it's a continuum. It's a collection of trade-offs. The higher version I go, the more of that .NET Standard goodness guarantee that I'm provided. If I go with .NET Standard 2.0, I get everything that I just showed you in terms of that list of APIs. You go lower, well, then you get broader reach, particularly when we start looking at some of the older Windows implementations, Windows Phone, and Silverlight, and so forth. This is actually not a new conversation. This is, as somebody who's been in the Java landscape for almost 20 years, and for somebody who's been particularly in the Android landscape for the last 10, it's actually a relatively easy algorithm. Part of the idea is you walk up to your project and you say, you know what? This people library doesn't use anything more than is provided by .NET Standard 1.0. I'm not making use of any of those other features, so therefore I can target this with the broadest reach. Now, if I start writing code that says, hey, I want to start doing Xlink queries and some of that, well, now I need to understand what level of support Xlink is, what level of .NET Standard support is required in order to use things like Xlink. And this is where the APIs of .NET can actually be quite useful. This is a collection of all Microsoft's assemblies here, and as you can tell, this is a really long list. All of the system namespaces across .NET Framework, pretty much any assembly that Microsoft has ever written, generally probably shows up inside of this list. So for example, if we're talking about Xlink and I'm saying I'm building my application such that I want Xlink support, that requires that I have system.xml.link. More importantly, in addition to all of this information here, we can see here down in the base, the bottom part of this screen, declarations. And specifically, we can see that it's provided as a part of .NET Core 1.0. We can see it as a part of .NET Framework 3.5. But most importantly to this discussion, here we can see that it's provided as a part of .NET Standard 1.0. So, my people library can actually make use of Xlink and still target basically every platform that .NET Standard has ever been after. The key thing to understand walking away from this particular discussion is that .NET Standard itself is not a platform. It's a specification. It's a guarantee. It's a promise from Microsoft to you, the developer, that says if you build something on top of .NET Standard, depending upon which version you select, we guarantee that all of the runtime library support goodness that you have come to know and love from the .NET framework will be present regardless of which implementation you run. So you decide to quit your dull, boring corporate day job and go into the glamorous lifestyle of video games because you want to build the next Angry Birds and you want to use Unity. And by the way, that's not a recommendation. The game industry is very cutthroat. Go into it with your eyes open. But you want to go down that path. You want to build your people library to be accessible to a Unity application. Once Unity implements the .NET Standard, once it is considered to be .NET Standard compliant, boom, you now will have all of that APIs of .NET listed stuff available to anything which is .NET Standard version X compatible. The .NET Standard is not a replacement for anything we've had before. It's not a new runtime. It's not a new language. It's basically just a sheet of paper that Microsoft has signed with you to say anything that is in fact .NET Standard has all of these features and all of this API that you've gotten used to from building on top of .NET Framework. It's a way to simplify code reuse across these different platforms so that you can focus on the important parts without having to be redundant and rewrite all of this stuff that you've already written once before for a different application that just happened to be WinForms. My name is Ted Neward. I've talked to you a little bit about the .NET Standard. Hopefully that makes things a little bit clearer for you. I want you to have a really good day. Take care.